Okay, this is a video to work through a specific part of this free response question. The question itself is based on fundamental theorem of calculus, and I think given the way the AP would likely craft the free response exam in this spring of 2020, that we would see some reference to this type of problem on it, just because it has a lot of different ways it can go. On this one, they gave us a graph. So they gave us the graph of f prime. And in part A, you went about finding a local minimum, which you would have found occurs at x equals 6. So your x value would be x equals 6. And you know you have a local min there. And let's see, that's 1, 2, 3, 4, 5, 6. That's right here. I'm just going to mark it on the graph. And the reason you know that's a local min is the derivative is changing from negative to positive at that location, which is what you would say in part A. So in part A, you would say, I know the derivative is changing from negative to positive. That's what it means to be a minimum. Here's where the minimum is occurring. And then in part B, it's saying figure out where the absolute minimum is. So you know you only have one spot where you have a local minimum. So this is now jumping forward to part B. So it's just a really brief look at part A. I'll even say f prime changes negative to positive, just to formalize what I was talking about there. When you get to part B, to have an absolute minimum on any function, you want to look at the places where you could have a local minimum. So in this case, that's only x equals 6. And then you also have to consider the endpoints. So you have to look at x equals 0 and x equals 8 in this case. The idea there is, and this is kind of an aside, but the idea going there is, you know, if you have a graph that maybe has, let's see, actually, let's use those numbers. So like at 0, we're there. Say we come down to a local min, but then we go down and do something like that. And the graph keeps going beyond it. So maybe that next minimum is at like a 10. But we're not seeing that in the picture because they only cut our picture off at 8. Well, at 8, maybe we're right here, and we've got an actual absolute minimum versus our local minimum. So the derivative helps you see the local minimum. That's how you see that change from being a negative slope to a positive slope. But we also have to look at the endpoints of the interval we're considering, because you potentially could have gone down below where that local minimum happened. So that's what they're asking for in part B, is for us to check these endpoints as well as the place where we could have a local minimum. So we need to look at 3 locations. And for what the AP is looking for on this one in terms of justifying their answer, you could just simply show them what the value is at each of those 3 locations. In order to do that, we've got to have some piece of given information. So I'm going to switch colors. You know what? Let's highlight it just for fun. There's our given piece of information. So that's what we're going to be using to do this problem. We're going to say, okay, f of 8 is 4. Well, actually, that actually gets us one of the values we're looking at. So that we know the function at 8 is 4. So that's one of our 3 items from the checklist. And now what we have to do is we have to look at the fact that they've given us areas. And actually, you know what? Highlighter would be good for this. So there's an area of 2, 6, 3, and 7. And the one piece on this is they're asking that you understand that's a negative space because it's below. So if you think about, okay, if I'm graphing a function on this same span, I know f of 8 is 4. So 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. So there's f of 8 is 4. There's 4, there's 8. And then I think, okay, so what happened from 6 to 8? Well, from 6 to 8, I picked up an area of 7, this positive space. So in other words, from 6, which is right here, to 8, I went up 7. Well, to go up 7 means at 6, you were here at negative 3. So I don't know how it went up. It doesn't have to be linear. It could be, in fact, it's not linear. But that part doesn't matter. What matters is that you understand that you went up 7 units. So this rise of 7 units, and I don't want to write too much on here, but this is our rise of 7 units, and that corresponds to this area of positive 7. So that means I went from a negative 3 up to a positive 4. So f of 6 would be negative 3. And that simply is the jump that occurs to get from this y value we didn't know up to the y value we did know. Another way to demonstrate that would be to say, okay, I've got 4, that's my f of 8, and then I'm going to subtract from that the integral from 6 to 8. So I'm going to subtract the integral of 6 to 8. Well, the integral of 6 to 8, that's an area. So this is area. So I'm going to subtract 7. So I'm going to do 4 minus 7, which is -3. And that minus just indicates, hey, you're moving right to left, or you're going backwards. But I think more intuitively, just thinking about where do you have to come from? So where does you have to come from? That's our -3 down here, to get to a finish line of 4. And to match with that 7, you would have to come from a -3. We can then go through that same process, just continuing to notch backwards through each of these areas and say, okay, the next spot of interest would be at 4. So at 4, there's a space of 3 right there. So from 4 to get to 6, so again, think forwards. From 4 to get to 6, I had to drop 3. So from 4, which is right here, to get to 6, I had to go down 3. So there we go. There's my down 3. And again, I should draw this smoother. I'm just putting in little linear chunks or maybe slightly curved chunks. But just kind of working back through each of these 4 highlighted pieces to get from 4 to 6, I got to drop 3. Well, there's my drop of 3. I then need to rise up 7. There's my rise up of 7, and that's going to land me at 4. Okay, let's work backwards again to get to 1. To get from 4 to 1, I should talk forwards. To get from 1 to 4, I need to gain 6. So I need to gain 6 to get from 1 to 4. So let's see, from 1 to 4, I had to gain 6. Well, let's see, so that means I have to go down 6. 1, 2, 3. So here, I'm at -6 when I'm at 1 because I need to pick up 6, or I need to add +6 from that spot, 1 over to 4. And then the same thought process from 0 to 1, you actually have to pick up 2. So from 0 to 1, we have to pick up 2. So there's our -8. So we're actually down here at 0. So f of 0 is -8. And again, let's work it forwards. If I start at a -8, so let's say I started at a -8. I'm then going to pick up 2. So plus 2. That gets me to -6. That means we're right here. Then I'm going to go from -6 plus 6. That gets me to 0. That means now I'm right here. Now I'm going to go from 0, and I'm going to subtract 3 because my area is below. That's going to get me to -3. Now we're here at 6. And then finally, I'm going to go from that -3, I'm going to add 7, and that's going to get me to 4, and I'm here at 8. And that's the finish line. That's the thing we're looking to hit. That thought process of checking back through and saying, okay, how would this look moving forward, I think is a good way to do it. In terms of what the AP is expecting you to do on this to show work, you would say, okay, well, f of 8 we know is 4. From that, I'm going to subtract the integral from, let's see, 0 to 8 of f prime. So I'm going to take 4 and I'm going to subtract away the integral. Well, subtracting away the integral, that means I'm subtracting away, what is that? 2, 6, -3, and 7. So 2, 6, -3, and 7. That's the integral, and you don't need to actually perform an integration or like do a numeric analysis. So now we're going to say, okay, that's 4 minus, let's see, 8, that's a 5, that's 12, so 4 minus 12, and sure enough, that's that -8 that we got to graphically. So in this case then, just to kind of bring it all back together, they gave us f of 8 is 4. We found that f of 6 was -3, and we found that f of 0 is -8. And that means if I look at these 3 potential places where you could have a minimum, or an absolute minimum, that would have to occur on the endpoint, on 0. So it actually mirrors the aside that we talked about, which at the outset of the problem I didn't know. I hadn't solved it or looked at a solution. But that thought process is the thought process I go through on each of these, which means our absolute minimum would be here. Your justification would be that you put together this table. If you really wanted to go overboard on it or make sure they know you know what you're doing, you can go through this integral of a derivative, and that is showing them you understand the fundamental theorem of calculus.